Well, there actually is a reason for learning how to do all this inverse stuff, and this lesson is the beginning of that. You're still not going to really see what the point is until about 2 more lessons, and then all of this stuff can be put to a really awesome practical use. But for now, we still need to learn one more thing, and that's to solve like an equation that has matrices in it. So on this one up here, don't write this down. I'm just going to show you a little something. One of the things that we want to be able to do is something like this. What this equation is something like this. It's negative 3x minus 5 equals 9. That's really all that is. If this was an algebra equation, of course we would add 5 and divide off the negative 3. Well, so I would of course go plus 5, negative 3x equals negative 6, and divide off the 3, and it's 2. Okay, well, matrices do something like that also. Now, one of the things that I want to just talk to you about is when you do this plus 5 right here, what you're really doing is the additive inverse. You're trying to make this add to 0. That's really what we're doing. So when you do this plus 5 to both sides, you're applying the additive inverse. And when you do this divide by negative 3, see, really it was multiplication at the beginning. So this is the multiplicative inverse, which makes it multiply to positive 1. So really what we're doing is the additive inverse, and the key word is inverse. We're doing the additive inverse here, and we're doing the multiplicative inverse here. So it's an inverse that allows algebra to work. We're either trying to add to 0, or we're trying to multiply to 1. Okay, so the key word, inverse. We're doing the inverse. Okay, well, we're still going to do the inverse. The inverse is what makes all of this work. So right off of the bat, what I see here is a matrix that's been subtracted. So I'm going to do the additive inverse of that. So I'm just going to add that matrix. So I'm going to go ahead and add this. So I'm going to add a negative 10, a 9, a negative 3, and a negative 11. Because now, so I maybe should have distributed that negative in there, but that's a negative 10 plus a negative 10. So this is a positive 10 plus negative 10, 0. This is a negative 9 plus a positive 9, 0. This is a positive 3 plus a negative 3, 0. This is a positive 11 plus a negative 11, 0. This matrix and this matrix add up to 0. It's the additive identity. Okay, so in order to get rid of this matrix, I'm just going to add the exact same thing so they add up to 0. Well, if you do it to the left, you have to do it to the right. So on this side, I'm going to add negative 10, 9, negative 3, and negative 11. Okay, let's see what we have. We've got negative 3x. Now this big giant, this x, notice it's a capital X. That means that's a matrix. A capital variable means there's some kind of matrix there. That's just not one number, that's a matrix of numbers. Equals, okay, over here I'm going to go ahead and add it up. So I've got a negative 11 plus a negative 10, so negative 21. Here I've got a negative 27 plus a 9, so negative 18. Negative 3 plus a negative 3, so negative 6. And 35 plus negative 11, so 24. Okay, now this number right here is just a multiplier. That means negative 3 times some big matrix right there. Well, that's a scalar multiplication. This is not a matrix times a matrix. This is just a scalar times a matrix. So to get rid of that, we can just divide by negative 3. And then it means I will divide this, or I could also think of that I could also think of that as times negative 1/3, same thing. I want to do that because if I'm going to multiply by negative 1/3 over here, I'm going to multiply by negative 1/3 over here. Okay, so I've got this matrix X left. And so basically I'm going to divide all of these by negative 3. So negative 1/3 times negative 21 will be positive 7. Negative 18 times divided by negative 3 will be positive 6. Negative 6 divided by negative 3 will be positive 2. And 24 divided by negative 3 will be negative 8. Okay, that's the answer. That's the matrix that makes this thing up here true. Okay, well let's see. Most of the time we don't have to do this, but I just want to check that to make sure we know what's happening. Okay, I'm going to plug that in up there and take a look at it. So what this is saying is I've got negative 3 times this matrix that I just got for an answer, 7, 2, 6, and negative 8, minus the matrix negative 10, 9, negative 3, and negative 11. That's supposed to equal this, if we did it right. Okay, well I'm going to take that negative 3 and multiply it in and see what we've got. Okay, well this is just a scalar right here, so let's go ahead and multiply it. So it's negative 3 times 7, so that's going to make a matrix of negative 21, negative 3 times 6, negative 18, negative 3 times 2, negative 6, and negative 3 times negative 8, 24, minus this one. Okay, well let's see, negative 21 minus negative 10, so negative 21 plus 10 would be negative 11. Okay, that one's right. Here I've got negative 18 minus 9. Negative 18 minus 9 would be negative 27. Okay, I got that one right. Negative 6 minus negative 3, so negative 6 plus 3 is negative 3. Okay, we got that one right. And the last one, 24 minus negative 11. So 24 plus 11 is 35. And sure enough, we have that one right. So there's our little check. That matrix that we had for an answer actually does make it equal to what it said it was going to do. So that's the algebra. It's really not very hard. Okay, let's take a look at number 2. It's almost the same thing. But now look, this one's going to be a little bit more significant. Now I've got a matrix times B, and B is capital, so B is another matrix. So this is going to be a matrix times a matrix, and that's much more difficult when we were doing the multiplications. So first of all, one of the things I'm going to do is just move this matrix over. So I'm going to add the negative 10, negative 6 to both sides. And now those two will end up being gone, and I have this 0, 8, negative 1, negative 3 times some other matrix B. It's going to equal 34 add negative 10, so 24, and negative 1 add negative 6 will be negative 7. Okay, now's the importance of when I was saying that this right here, what I just did, was the additive inverse. It takes the inverse to get rid of addition, and it takes multiplicative inverse to get rid of multiplication. But this right here is not multiplication. It's not normal multiplication. It's matrix multiplication. So I need a matrix inverse to make it go away. So I need the inverse of this in order for it to go away. So I'm going to come over here to the side, and hopefully I remember how to do the inverse. The inverse of a 2 by 2 is 1 over the determinant, and then the A and D are going to switch places, and B is going to get negated, and C is going to get negated. That's how we found that inverse. Okay, so first I got to find the determinant. I'm going to try to squeeze it in right over here. So, okay, the determinant, just the determinant, is 0 times negative 3 minus negative 1 times 8. So that's going to be 0 minus negative 8, so it's 8. So the determinant is 8. So the inverse, the inverse of this thing, of this, I'm calling this the A, the inverse of that is 1 over 8 times the D number, so that's going to be, the 3 is going to come up here, the A, which is the 0, is going to come down here, the 8 gets negated, and the negative 1 gets negated. Okay, for this purpose, I'm going to go ahead and multiply that 1/8 in there. So the inverse is negative 3/8, negative 1, negative 1/8, and 0. I just took this 1/8 and multiplied it all the way in there. Okay, so there's our inverse. So I need the inverse in order to make, in order to get rid of this, I need to multiply it times its matrix inverse. Okay, order matters. So we're going to put the inverse first. So I want to write it like this, A inverse times A. Now it's not going to matter over here because that's just going to, well, let me not circle that one. That's going to end up being the identity matrix. But it is going to matter over here, so we want to put it in the front. Okay, so I'm going to go ahead and, I got to remember what it is. Negative 1, negative 3/8, negative 1, negative 1/8. So over here, I'm going to multiply by negative 3/8, negative 1, negative 1/8, and 0. Let me make sure that's what it was. Negative 3/8, negative 1, negative 1/8, and 0, yes. Okay, well, now this is going to go to the identity matrix. But if I do something to the left, I have to do it to the right. So I'm going to multiply the other side by that same identity matrix. Negative 3/8, negative 1, negative 1/8, and 0. Okay, so here's what our B matrix is going to be. Our B matrix is just that. I'll write it out a little bit easier to see. Negative 3/8, negative 1, negative 1/8, and 0 times the other matrix 24 and negative 7. Now this may not even go together. Remember, not all matrices multiply together. So this one over here is a 2 by 2. I'm trying to multiply this by a 2 by 1. These two numbers have to be the same, which they are. Okay, that means these two numbers are going to be the answer matrix. So the answer matrix is going to be a 2 down and 1 over. So it's going to be a 2 by 1 like that. Okay, well, let's multiply that thing together and see what we have. Okay, so I need to take this row times this column. So this row times this column will get me that row. It'll get me the top one. So I have negative 3/8 times 24 plus negative 1 times negative 7. Okay, well that 8's going to reduce the 24 down to a 3, so that's negative 3 times 3, so that's negative 9 plus 7 times 1 is 7, so that's a negative 2. There's that one. And now I'm going to do this row times this column. So that's going to be the negative 1/8 times 24 plus then the 0 times negative 7. So it's just going to be negative 1/8 times 24. Well, same thing. 8 reduces that 24 down to a 3. So I've got negative 3 plus 0, so negative 3. So there's the solution to that one, negative 2, negative 3. Now you've probably noticed that I make a lot of mistakes doing this because I don't pay very close attention to addition. That's not a very good habit that I am in, but it happens. So I can notice a mistake I have way back up here. So let's take a look at it. that 1/8 times 1. 1/8 times 1 should be positive 1/8 right there. So when I get done, I always check my answer. I push pause and I check my answer. That's how come sometimes I have to go back and figure out where it went wrong. That's positive 1/8. Okay, that means that's positive 1/8 right there. So right here when we were doing this one, it should be positive 1/8 times 24. So these were positive 1/8, which means this one right here is positive 1/8, which actually makes that positive 3. So our answer is -2, positive 3. It's that matrix, -2, positive 3. Now, when we're done with this section, I'm going to show you a way that I do all the time where I don't make mistakes, but you'll just have to bear with me when I don't pay attention very well to addition and subtraction. Now, that's actually a habit that I don't want you to be careless like I am necessarily, but I do want to impress upon you that the answer is so much less important than the process. Yes, the answer should be right, and I should not be making those kind of silly errors, but it's the process that I'm much more concerned with. That's why when I look at some of your papers and I give them back to you and I say, I can't follow your thought, I want to follow your thinking. I don't want to look at the answer and just say yes or no. I want to follow what you're doing. And especially with this matrix thing and inverse thing, there's so many different ways to do it. I'm going to ask you to do it all kinds of different ways, so I need to see the work that you have. Okay, so with that said, I'll try to be more careful, but no guarantees. Okay, so right here, I need to get rid of this one with additive inverse. So this is a positive little matrix. So I'm going to subtract this little matrix over here so that they add up to 0. Okay, well, if I subtract it on this side, I've got to subtract it on this side. So this one's going to get a 0, 1, -1, 7. Okay, just like in algebra, let's bring down what we have. Okay, I've got negative matrix 10, 2, -9, -1 times the capital C, so that's times a matrix, equals 24 minus 0. Negative 24 minus 0, it's going to be -24. All right. -19 minus 1, so -20. 15 minus -1, so 15 plus 1, 16. And 17 minus 7 for 10. Okay, this -1 over here is really that negative is really a -1 multiplied times this matrix. So it's just a scalar. I can divide off a -1, so those are gone. So I'll divide this side by -1. So now here we have this 10, 2, -9, -1 times some other matrix C is equal to, now all these on this side are just going to be divided by -1, so we'll change all their signs. So it's going to be 24, 20, -16, and -10. Okay, now I just need the inverse of this so I can make this go away. Just like this went away with additive inverse. This went away with multiplicative inverse. This is going to go away with matrix inverse. So I need the matrix inverse of that. Okay, so first I need the determinant. The determinant of A is going to be these two minus these two. Okay, so the determinant is going to be 10 times -1 minus -9 times 2. So -10 plus 18, so it looks like it's 8. So the inverse of A is 1/8 times the matrix. Okay, we've got to switch the order of these two. So that's going to put the -1 up here, positive 10 down here, and then we're going to negate these two. So it's going to make it -2 and +9. So I'm just going to multiply that in now. So multiplying the 1/8 in there gives me an inverse of -1/8, -2/8, which is -1/4, 9/8, and 10/8, which is 5/4. So there's our identity matrix. What that means is up here, if I multiply this times that matrix of -1/8, -1/4, 9/8, and 5/4, these two make the identity matrix. So I'm just going to trust that I did that right, and we'll see here in a minute if I did. So that's going to give us just C. Okay, well, if I do that red matrix to the left, I've got to do it to the right over here. So I'm going to multiply this piece over here times that same inverse matrix. So -1/8, -1/4, 9/8, and 5/4. Okay, let's see if it can actually be done before I even waste my time. So here, this one is a 2x2, and this one is a 2x2. Okay, those two are the same, so that's good. That means the answer is this, the size out there. So it's going to be a 2x2 matrix. Okay, so I'm going to start with this one. I want this row times this column. So that's going to be -1/8 times 24 plus -1/4 times -16. 8 goes into 24 3 times, so that's -1 times 3, plus 4 goes into 16 4 times. 2 negatives makes it positive, so it looks like that spot is a 1. Now I'm going to do this spot. How about the 9/8 row times the 24 column? So it'll be 9/8 times 24 plus 5/4 times -16. Okay, 8 goes into 24 3 times again, so 9 times 3 is 27, plus 4 goes into 16 4 times, so -20, so it looks like that spot is 7. Okay, now I'll do the top row with the second column, so -1/8 times 20 plus -1/4 times -10. Okay, that's -20 over 8, which is 10/4, which is 5/2. So I got -5/2 plus negative, so plus 10/4, which is 5/2. So I got -5/2 plus 5/2. So it looks like that spot is 0. And then the last one will be that row times this column. So 9/8 times 20 plus, no, not 9/8. Yes, 9/8. 9/8, this one, 9/8 times 20 plus 5/4 times -10. Let's see what we get out of that. Oh, let's see here. 4 can go in there twice, and 4 can go in there, 5 times, so 45/2. Plus 2 goes in there twice, and in there 5 times, so 25/2, -25/2. 45/2 minus 25/2 is 20/2, so it looks like this spot over here is 10. There we go. That's matrix C. Okay, let's look at number 4. Let's do one more. Okay, right off the bat, I'm just going to add this matrix to both sides. So I've got this 1, -2, -3, 6 times the matrix A equals, let's see, 14 plus -11, so that's 3, 6 plus -4, that's 2, 0 plus -9, that's -9, and 3 plus -9, -6. Okay, so I need the inverse of A over here. So let's take the determinant. So the determinant is going to be these two minus these two. So it's going to be 1 times 6 minus negative 3 times negative 2. So that looks like 6 minus 6, 0. So I've got a determinant of 0. So when I go do the inverse, it's going to be a 1 over 0 times, switch the order, 6 and 1, negate the other things, 2 and 3. You can't not have 1 over the 0. There's no inverse. And when there's no inverse, that means this A has no solutions. There's no such matrix that will actually make this work or this up here work. There's no A that makes this happen. The end.